Alright, Objective 39 and 40 brings up two new rules that we're going to be using throughout this unit. Those are the product and the quotient rules. Let's start with the product rule. I'm going to give you an example and see if we can make some sense of this. The example is x to the fifth times x to the third. From our previous objective, we know that x to the fifth can be rewritten as x times itself 5 times. So x times x times x times x times x. We also know that x to the third can be rewritten as x times itself 3 times. From here, we can figure out how many x's do we have. We can count them out. 1, 2, 3, 4, 5, 6, 7, 8. Our solution is x to the 8th. Now, is there a way that we can determine that x to the 5th times x to the 3rd equals x to the 8th? You may have already noticed, but our solution, the exponent, is going to be the sum of the exponents of our factors here. In order to add the exponents here, we must have the same base. Notice these are both base x. In general, we can write this rule as if we have x to the a times x to the b, that is equal to x to the a plus b. Again, we have the same base. We can multiply these two terms together, and we get this exponent is the sum of these exponents, a plus b. Let's practice. Here we have c to the 4th times c to the 8th. We could write this out, c times itself 4 times, times c times itself 8 times, or we can rewrite this as the sum c to the 4 plus 8, or c to the 12th. Here we have d to the negative 3 times d to the 5th, so we can rewrite this as d to the negative 3 plus 5. Negative 3 plus 5 gives us a positive 2. So our solution is d squared. Notice that our base doesn't change. Next, we have e to the negative 8 times e to the positive 8. We can rewrite that as e to the negative 8 plus positive 8. E to the negative 8 plus positive 8 gives us e to the 0. And what we know from our previous objective, anything to the 0 power is 1. Looking here, we have 4a cubed times negative 2a to the 4th. We multiply numbers with numbers and variables with variables. So we can multiply 4 times negative 2 to get negative 8, and then we have a cubed times a to the 4th, or a to the 3rd power times a to the 4th power. We can rewrite that as a to the 3 plus 4, which is a to the 7th. Here, again, we multiply numbers with numbers, variables with variables. Negative 9 times negative 3 gives us a positive 27. Our d term, we have d to the positive 3 times d to the positive 4. So we can write that as d to the 3 plus 4. And then our e term, we have e to the negative 4 times e to the 2. So we have e to the negative 4 plus positive 2. We have 27. D to the 3 plus 4 is d to the 7. And e to the negative 4 plus 2 is negative 2. Now, we don't want any negative exponents in our answers. As a reminder, a negative exponent flips the fraction. So we look at each term, each factor. Does our 27 have a negative exponent? No, we can leave that in the numerator. Does our d to the 7 have a negative exponent? No, we can leave that where it is too. Does our e to the negative 2 have a negative exponent? Yes, so we flip that to the bottom. This is our solution. Last, we have 2 times negative 8 gives us negative 16. And then our a, we have negative 4 and negative 3. So plus a negative 3. And then our b term b to the 2 plus negative 5. Okay. We have negative 16. Negative 4 plus negative 3 is negative 7. And 2 plus negative 5 gives us a negative 3. We've got negative exponents, so you can just go ahead and draw your fraction bar. Does our 16 have a negative exponent? No, so we can leave it where it is. Here our a to the negative 7 does, so we're going to flip it. Instead of being on the top, we're going to now be on the bottom. And likewise with the b to the negative 3, that's got a negative exponent, so that flips to the bottom as well. So our solution, negative 16 over a to the 7th, b to the 3rd. Flip the page and we'll talk about the quotient rule. The quotient rule is similar to the product rule, but now we're dividing. So an example, if I have a to the 8th power over a to the 3rd power, well, let's break that down. We know we have a to the 8th can be rewritten as a times itself 8 times. We also know that a to the 3rd can be rewritten as a times itself 3 times. Here, everything is being multiplied in the numerator and everything is being multiplied in the denominator. We can cancel out some of these factors. In order to cancel out, you must have an a in both the numerator and the denominator. What's left over? Well, we just have 1, 2, 3, 4, 5 a's in the numerator and 0 a's in the denominator. So how can we know that a to the 8th over a to the 3rd is equal to a to the 5th? You may have already guessed it. It's the difference of the numerator and the denominator, or a to the 8 minus 3. In general, we can write this as if we have x to the b over x to the c. The quotient rule tells us that our solution is x to the b minus c. We take the difference of the exponents. Let's practice. Here we have x to the 11th over x to the 15th. This is equal to x to the 11 minus 15. 11 minus 15 is negative 4. And again, we don't want any negative exponents in our solution. So we can always put it over 1 and it's going to flip our fraction and we use the positive exponent. So instead of x to the negative 4 over 1, we get 1 over x to the positive 4. That is our solution. Here we have p to the 10 over p to the negative 7. So we take the difference, 10 minus negative 7. 10 minus negative 7 is the same as 10 plus positive 7, or p to the 17. Here we have 2 to the 18 over 2 to the 7th. This is the same as 2 to the 18 minus 7. 18 minus 7 gives us 11. And anytime your base is a number, we want you to evaluate. We know 2 to the 11th is 2 times itself, 11 times. Plug that into your calculator and you get 2048. Here we have 6a to the 10th over 2a to the 14th. Just like when using the product rule, we're going to work numbers with numbers and variables with variables. So starting with the numbers here, 6 divided by 2, that gives us 3 over 1. And then we have a to the 10 and a to the 14. We can take the difference of the exponents of a to the 10th and a to the 14th. This is the same as 3 times a to the 10 minus 14. 10 minus 14 is negative 4, so we have 3a to the negative 4. Again, we don't want any negative exponents, so we can flip it down to the denominator. So 3 does not have a negative exponent, so that stays in the top. The a to the negative fourth does have a negative exponent, so that moves to the bottom. So we have 3 over a to the positive 4. That is our solution. Here, we've got a to the 18 over a to the negative 16. We can take the difference of those exponents, a to the 18 minus negative 16. And then we've got b to the negative 9 minus b to the, what's our exponent? Anytime there is no exponent, you can just write 1. The exponent is 1. A to the 18 minus negative 16 is the same as a to the 18 plus positive 16, or a to the 34th. Negative 9 minus 1 is negative 10. Again, we don't want any negative exponents, so we got to move that. The a to the 34 does not have a negative exponent, so that stays in the top of our fraction. And the b to the 10th moves to the bottom. And then we flip it to a positive exponent. So we have a to the 34 over b to the positive 10. Lastly, we have 15 over 30. We can factor out a factor of 15. So we get 1 over 2. And then we have z to the 20 minus 4. Z to the 20 minus 4 is just z to the 16th. So we have 1/2 z to the 16th. And if you'd like, you can move this z into the numerator. You can also get z to the 16th over 2. Either of these solutions are fine. And that's objective 39 and 40, the product rule and the quotient rule.